Hi everyone, this is Professor Turner with Purdue Polytechnic, and you're watching a video lecture for ECET 364, a course on the fundamentals of electromagnetics. Today's topic is our second video on plane waves, and what we're interested in particular is what's going to happen if in a plane wave if I have it traveling in some sort of medium and then all of a sudden it sees a new medium. So if it's traveling in air and it goes into glass, or if it's traveling in a vacuum and it enters the Earth's atmosphere or something, well, what happens to this plane wave? The specific learning objectives that we're going to cover today, there are two of them. The first is that we're going to understand EM plane wave polarization. By that we mean which direction does the E field of the plane wave point relative to the Earth, and we'll explain that in more detail. But plane waves can point in certain directions, and how they behave is very much influenced by the direction in which they point. And then after we figure out how to categorize plane waves for pointing in different directions, we're going to use that information to calculate the transmitted and reflective waves at different impedance boundaries. And we're going to look at three types of polarization: TEM polarization, TE polarization, and TM polarization. So as you may expect from your knowledge about transmission lines, what happens is that when we have an EM wave traveling it sees an impedance boundary, that incident wave will be reflected, or some portion of it will be reflected, and some portion of it will be transmitted. And depending on the polarization, different amounts will be transmitted and different amounts will be reflected. So it's dependent on material properties and dependent on this polarization, as you will see.